Hello, welcome to this tutorial on tools to detect and diagnose floating point errors in heterogeneous computing hardware and software. My name is Ganesh Gopalakrishnan, and I will be leading you through the tutorial that consists of three parts. The first is a tool for exception detection in LLVM codes presented by Dr. Ignacio Laguna of Lawrence Livermore Labs. The second will be a tutorial on the GPU-FPX and nixnan tools jointly presented by Mark Baranowski and Ganesh Gopalakrishnan, myself. Mark is a postdoc. And the third tool will be FloatGuard, presented by PhD student Dolores Miao and her advisor, Cindy Rubio-Gonzales. So when executions are subject to different values in a floating point domain, one can generate exceptions. And one easy way to detect those exceptions is to use the technologies provided by LLVM, where we can instrument the code, which could be a wide variety of languages. And basically, one can insert checks for floating point exceptions after every floating point operation finishes. So such a tool that provides detailed reports has been provided and released from Lawrence Livermore Labs. And this is the first tool that will be presented. The tool provides intuitive reports summarizing the different exceptions and also the locations in which these exceptions are found. What the tool does is it actually looks at the results calculated by a floating point operation and finds out whether an exceptional value is indicated and then compiles a detailed report. The tool FPChecker also includes a detailed view of the exponents encountered during the program execution, which can help the programmer understand which number ranges and binaids are getting used in their execution. The second tool pertains to NVIDIA GPUs, which differ from other GPUs in that they have their own hardware consisting of SIMD cores and tensor cores. And they have provided a binary instrumentation tool along with their distribution, which allows you to trap exceptions whenever a kernel is launched. And what we are interested in is not only detect exceptions in the SIMD, single instruction multiple thread cores, but also the tensor cores. And you can actually see that the tool can produce exceptions summarized according to various categories. And also, when the tensor cores perform matrix multiplications, you can actually get an indication of the exceptions propagated through these matrix operations. The tool actually works at the SAS level, which is the lowest level of the machine instructions, which actually helps the tool accurately understand floating point operations and optimizations. And also closed libraries might generate exceptions, which can be picked up by GPU-FPX. We improved the GPU-FPX tool to include many more number formats, a certain set of bug fixes that allows the tool from persisting despite finding exceptions, and also extensive support for FP16, and last but not least, the tensor cores. So these are the instructions and executions shown in detail. The last tool that we'll be presenting will be pertaining to AMD GPUs, which differ from NVIDIA GPUs, and yet are increasing in use in supercomputers at Lawrence Livermore Lab and many other labs. And they do not readily provide facilities for examining exceptions. They require per thread activation and manual debugging as things stand. So what we do is we instrument the HIP programs, HIP, which is what AMD GPUs are programmed using. And we link our instrumentation code at the assembly level. And the linked executables are compiled and run. And an initial set of exceptions are noticed. And then the tool suppresses those locations where the exceptions were detected, thus enabling exceptions later in the execution stream until all the exceptions have been compiled and reported. So I hope you would join us for the supercomputing half-day tutorials, which will feature all these three tools that focus on three different approaches to floating point exception detection. And exceptions are actually detrimental to program executions in the sense it may pollute the loss function or the residual. And one has three different options, one at the LLVM level, one for NVIDIA GPUs and one for AMD GPUs. So hope you can join us for this unique presentation. Thank you so much, and see you at the tutorial.